In this video, we will discuss example 2 for RL circuits under Kirchhoff Law. Okay. The question is, in a circuit containing inductance 2 henries, resistance 10 ohms and voltage 30 volts, the current in the circuit is given by L di over dt plus IR equals to ET. Show that the current in the circuit at any time t is given by I equals to 3 minus 3 e to the power of negative 5t, right? To solve this question, first we need to extract the given information, which is L, R, and ET, right? From the given question, we have inductance 2 henries. Okay, this is L. Okay, so we can write here L equals to 2 henries. Okay, and then resistance 10 ohms. Okay, this is R. Okay, so we can write here R equals to 10 ohms. Okay, this is the symbol for ohms, right? Then we have voltage 30 volts. Okay, this is ET. Okay, so we can write ET equals to 30 volts. Okay. And then the question is, show that the current in the circuit at any time t is given by I equals to 3 minus 3 e to the power of 5t. Means we need to find the current I in terms of t, and then we need to show that the answer equals to 3 minus 3 to the power of 5t, right? And then when we integrate, we will have plus c at the back. Okay? And to find the value of c, we need to use the initial condition when time equals to 0, the current equals to 0 ampere. Okay? So this is to find the value of c. Okay? We use this information after integration, right? After we extract the values of L, R, and ET, then we start with the given formula, right? From the given formula, L di over dt plus IR equals to ET, we substitute L, R, and ET into this formula. Okay, so after we substitute, we got this. 2, okay, we replace L equals to 2, di over dt plus I, and then we replace R equals to 10 equals to, we replace ET equals to 30. Okay, after that, we need to write coefficient of di over dt equals to positive 1. So, what should we do? Okay, we need to dividing each term by 2. Okay, alright, after we dividing each term by 2, so we got this, okay? di over dt plus 10 divided by 2 equals to 5. So we got plus 5i equals to 30 divided by 2 equals to 15. Okay? From here, this is similar to pure linear equation under first order ODE. Okay? If we compare from this linear equation, okay, y similar to I, okay, which is current. X similar to time, okay, which is t, right? And then this is y similar to I, so our px equals to 5 and our qx equals to 15. But in this case, our pt equals to 5 and our qt equals to 15. Okay, under linear equation, the most important thing we need to find integrating factor, which is IF. Okay, and the formula for IF equals to e to the power of integration of px dx. Okay, px in this case equals to pt, which is equals to 5. Okay, so to find IF, which is integrating factor from this linear equation, we use this formula, okay, E, and then to the power of integration of PT equals to 5, and then dx now equals to dt. Okay, after we integrate 5 with respect to t, we got 5t. So our IF now equals to e to the power of 5t. Okay, and then we recall back under linear equation for first order ODE. After we find integrating factor, we need to find the solution for y. Okay, in this case, we need to find the solution for I, right? So we recall back, okay? We use formula y times if equals to integration of qx times if dx, okay? So in this case, we can write I, okay, which is similar to variable y, times if. Our if now equals to e to the power of 5t equals to integration of qx, okay? In this case, we have our qx or qt, okay, in terms of variable t, which is time, equals to e to the power of, our qx now equals to 15, okay, and then times if, and then dx now equals to dt, okay. So from here, okay, since we have integration sign for the right hand side, so we need to integrate, okay. So for the left hand side, we don't need to integrate, okay, we just write back I equals to e to the power of 5t equals to, we have constant 15 here, and then after we integrate e to the power of 5t with respect to t, we got e to the power of 5t over 5, okay. And then since this is indefinite integral, so we need to put plus c at the back, right? After that, we can simplify 5 and 15 here, okay. So after we simplify, we got 3, okay. 15 divided by 5 equals to 3, okay. Then we can write I times e to the power of 5t equals to 3 e to the power of 5t plus c, okay. And after we integrate, okay, since we integrate indefinite integral, okay, and we put plus c at the back here, so after that we need to find the value of constant c. So how to find the value of constant c, okay, using this information, okay. When time equals to 0, the current equals to 0 ampere, okay. So we can use this information to find the value of c after we integrate, right? So when t equals to 0 and I equals to 0, after we substitute into equation 1, so we got this, okay? 0, okay, 0 times any value equals to 0, and then equals to 3 times e to the power of 0 plus c. E to the power of 0 equals to 1, okay? So we have 0 equals to 3 plus c, okay. And after we solve for c, we got c equals to negative 3, okay. Then we can substitute the value of c into equation 1, okay. So after we substitute c equals to negative 3 into equation 1, so we got this, I times e to the power of 5t equals to 3 e to the power of 5t and then minus 3, okay. I means current, okay. After that, we can write I as a subject to find the current at any time t, okay. So to write I as a subject, we can move e to the power of 5t to the right hand side, okay. Since this is multiplication operation, so after we move to right hand side, we can divide all the term from right hand side, we divide it by e to the power of 5t, okay, like this, okay. So here we have I equals to e to the power of 5t over e to the power of 5t, and then minus 3 over e to the power of 5t, okay. Then we can write I, okay, which is the current in the circuit at any time t equals to, after we simplify, we have I equals to 3, okay, because we simplify e to the power of 5t over e to the power of 5t, okay, from numerator and denominator, and then minus 3, using the properties of indices, we can move up e to the power of 5t. After we move up, we can write e to the power of negative 5t. Okay, and then we compare with the given I, okay, and it is exactly the same. Okay, means we done shown I equals to 3 minus 3e to the power of 5t. Okay, this is the current in the circuit at any time t. Right? Got it? This is the complete solution for this example. Right?